Alright, good day to Sir Ali. Today I'm gonna show our PBT OSA, and this is my group member. So firstly is the question, can design concept. Alright, so this is our design concept. It's asking us to develop a topology, identify necessary network components such as router, switch, server, and firewall, and present the graphic design visually. So as you can see on the right, the picture, this is our topology, sorry. And as you can see, the router, the switch, the server, and the cloud are all there. So yeah, this is our topology. Alright, so next is service implementation overview. Explain the purpose and importance of the chosen service in the CAN. So first is the domain name service DNS translates domain name into IP address, enabling easy access to network resources. Implementing a centralized DNS in Greentech University will simplify access using host names, enhance security by preventing DNS hijacking, and improve reliability through caching. It also supports scalability for future expansion and ensures faster access to internal systems, addressing previous issue of slow connections and data risks. Next is list all software and hardware prerequisites such as Linux distribution package system requirement. So first is Linux Debian 12 or 13 or Ubuntu LTS or similar for Debian installed on two VMs, one for server and one for client. Next, the package we use is Binine utils, Binine doc, and the NS utils to allow the NS configuration. Next is firewall. This is optional, and same goes to Binine Matrix Exporter for monitoring. And our hardware is two server with stable storage and NICs, backup storage for zone files. So next is configuration setup. So we need to configure DNS, and firstly we have to sudo apt get update to update the package and find the latest one. Here after sudo apt get update, we install the Binine utils. So after install the Binine, we will edit the etc bind and conf option folder using the nano command. In here, first we will put the recursion to yes. We also allow query to any, then edit the forwarder to add 44. Then as validation, we put to auto. Listen on v6, we put to no. After edit conf option, we edit conf local. So in here we edit to add the zone. So the zone that we add is greentech.edu.my. Type master because server is master. The file is etc bind db greentech.edu.my. Allow transfer to 10.0.0.10. That is the IP address of the client. Next step is to create the zone. So the command to create the zone is sudo cp etc bind db.local etc bind db.greentech.edu.my, and then edit the greentech file using the nano command. Here we edit the zone. We change the here to put ns1 greentech.edu.my and then admin greentech.edu.my, and below we add the www in a pointer and then 10.0.0.129 as the IP of the server. Then we're gonna check the zone. So we use the command name check conf and then check zone greentech.edu.my etc bind db.greentech.edu.my to ensure that our zone is there. Then as always, after edit the binary, we need to restart it using the systemctl command. So here we're gonna edit the file in Slav after we done edit the file in server. First, we edit the name conf.local in slave. Here we type the same zone as the server, which is greentech.edu.my, but change the type master to type slave and put the master to 10.0.0.129 as the IP of the master, and the file is file varchar bind db.greentech.edu.my. So lastly, to ensure that our DNS is connect, we ping server to slave or other way like slave to server. Next is question 4, process documentation. So what include in our lab is the VM and the host list and the screenshot of our command. So this I already explained in the previous part, which is question 3, like always. So that's all in part 4. Next is question 5, which is final summary and maintenance plan. So first is final summary. The DNS maintenance and monitoring plan includes installing monitoring tools such as Prometheus, Grafana, or Nagios to track query rates, failed queries, and system performance metrics like CPU, memory, and disk usage. Logs from bind should be regularly rotated, reviewed, and forwarded to a centralized log server using RESLog or ELK. Daily backup of etc bind and zone files must be stored securely off server. Zone files updates should follow a version control process using Git to prevent configuration errors and ensure automatic serial updates. Security measures include limiting recursion to internal networks, enabling DNSSEC using TSIG for secure zone transfer, and keeping the server updated and hardened. For high availability, additional slave server and caching resolver should be deployed across campus to balance load and increase redundancy. Disaster recovery procedures must be documented with off-site backups maintained and tested regularly to ensure smooth restoration if the primary server fails. And next is maintenance plan. Future improvement for the DNS system include integrating it with the university LDAP or Active Directory to enable dynamic updates and automation. Internal private zones such as campus greentech.local can be created along with split horizon DNS to provide different views for internal and external users. Implementing the NSSEC will ensure end-to-end data authenticity and security. Additionally, deploying alternative DNS server in geographically spread or cloud-based location will enhance redundancy and disaster resilience, ensuring continuous. That's all from us. Thank you.